Repetition method exam question number 1. The stress required to double the length of a wire of Young's modulus. Young's modulus is equal to stress over strain. Here they asked to double the length. That means if the original length is L, the extension also L, then only the final length will be doubled. Therefore, strain is equal to change of length over original length. Here both are equal. A change of length and the original length are equal, therefore strain is 1. Therefore, Young's modulus is equal to stress over strain. Strain is 1, therefore Young's modulus is equal to stress. Question number 1, answer number 2 is correct. A uniform wire is made from a material of Young's modulus Y and has an unstretched length L and radius R. Upper end of the wire is fixed to the rigid support. And a mass M is suspended from its lower end. Mass M means the weight is equal to mg. Its natural length is equal to L and the radius is equal to 2r. Length of this wire at equilibrium means, first we can find the extension. Y is equal to FL over AE. You can subject E is equal to FL over AY. What's the force? Force is weight mg. Length is L. Area is pi 2r holding square. Radius is 2r into Young's modulus Y. It has a final length at equilibrium means we have to add the extension with the original length. Original length is L. Elongation also mg. L over 4 pi r squared into Y. You can comment out L. Then 1 plus mg over 4 pi r square into y. Question number 2, answer number 4 is correct. As the radius is 2r, area is 4 pi r square, area is in the bottom. There are two answers with 4 in the bottom, 4th and 5th. But the length will be added. The final length is equal to original length plus extension, not subtraction. Therefore, 5th one is wrong, 4th is correct. Question number 3. A ball of mass m and radius r is released in a viscous medium of negligible density. Its terminal velocity is proportional to. When a ball is falling, generally 3 forces acting. One is weight, other one is viscous force, the third one is upthrust. Here upthrust is negligible because they set negligible density of medium, therefore rho 0 means upthrust also 0. Therefore only forces acting on the ball is F and mg. Therefore at terminal velocity, F should be equal to mg. F can be substituted by Stokes equation 6 pi neta RV and mg. Here 6 is a constant, pi is a constant, eta for a medium is constant, g also constant. Therefore, the velocity, terminal velocity is proportional to mass over radius. Second one is correct. Method 2. The general equation for the terminal velocity is 2r square rho minus sigma g over 9 eta. Here is mentioned that density of the medium is negligible. You can put 0 for sigma. Then it becomes V0 is equal to 2r square rho g over 9 eta. Here you can remove the constants. 2 is a constant. G is a constant, 9 eta is a constant. Therefore, terminal velocity is proportional to r squared rho. But we have to bring the mass inside. Mass of an object is equal to volume into density. Actually, volume is proportional to r cube. Therefore, mass is proportional to r cube into rho. Therefore, how to bring r cube inside? You can multiply up and down by r. Therefore, V0 is proportional to r cube rho over r. Instead of r cube rho, you can put mass. Therefore, MO1. For this method also, you can get the answer. But the fundamental method is easier. This is not a standard equation. You can't directly use it for second part. Here, for the first method is better. Question number 3, answer number 2. A steel wire having a radius of 2 mm carrying a load of 12 kg is hanging from ceiling. The tensile stress that would be developed in the wire is approximately. The stress is equal to force over area. The force is the weight of the object. 12 kilogram means 120 Newton. Area is pi r square. Radius is given. You have the circle area pi. The radius is 2 mm. 2 into 10 to the power of minus 3 for converted to meter square. As it is given approximately, you can take pi is equal to 3. Therefore, 120 over 3, 2 square is 4, 10 to the power of minus 6. 12 and 12 is cut off. Minus 6 came off, become plus 6. Therefore, 1 into 10 to the power of 7 Newton meter minus 2 is a stress formed in that wire. Therefore, question number 4, answer number 3 is correct. Question number 5. Two solid spheres P and Q, each of density 8, have diameters 1 centimeter and 0.5 centimeter. One has a diameter of 1 centimeter, second one has a diameter of 0.5 centimeter. Density, both are same, 8 gram centimeter minus. Sphere P is dropped into the liquid of density 0.8. Here densities are same for both objects. The densities of mediums are different. First one is 0.8 gram centimeter minus 3. Second one is 1.6 grams centimeter minus 3. And the viscosity of the media are also different. First one 0.3 Pascal second. Second one 0.2 Pascal second. Ratio of the respective terminal velocities of P and Q. Just you can directly substitute. The equation for terminal velocity is equal to 2 r square rho minus sigma g over 9 eta. You can substitute the data for 2 times and divide 1 by 2, you will get the answer. First Vp, here 2 is constant, 9 is constant, g is constant, is proportional to, no need to convert it to radius because ratios of diameters and ratios of radius will be same. Therefore 1 squared, this is 8 minus 0.8, no need to convert for SI unit because they will be cut off, over viscosity is 0.3. Vq proportional to half squared, 8 minus 1.6 over 0.2. If you solve them, you will get the ratio Vp over Vq is equal to 3. Method 2, you can do little faster. Vp over Vq is equal to ratio is 2 times larger for P, therefore R squared is 4 times larger. If you take the density of first medium as D, then the density of object is 10D. Therefore, if you subtract, that is 9D. Similarly, if you subtract for the second one, this is 2D, this is 10D, therefore the difference is 8D. The terminal velocities are inversely proportional to the coefficient of viscosities. Viscosities are in the ratio of 3:2, therefore they are inversely proportional, therefore it will be 2:3. Then if you solve them, D and D cut off, 4 into 2, 8 will be cut off, 9 and 3 will be cut off, answer is 3. In both ways you can solve them, this will be a little faster. For question number 5, answer number 5 is correct. Question number 6. This is hydrostatics part. If it is in equilibrium like this, obviously the density of the second media is greater than first one because it is the bottom. We are lifting the object Q. That means if the rope is removed, it will go down. Therefore, obviously the density of rho 2 is greater than sigma 2. The P1 is like a balloon. You are pulling it downward. If you release the wire, it will go upward. That means the density of rho 1 is less than sigma 1. Therefore, we got a relationship among the densities of the 4 objects, P, Q, liquid 1, liquid 2. Right. Now, it is given that P is let to fall in the second medium, L2. And Q is let to fall in the first medium. Actually, rho 2 is greater than sigma 2 means obviously rho 2 is greater than sigma 1 also. Therefore, it will move downward. Therefore, its terminal velocity will be in the downward direction. But here, rho 1 is lesser than sigma 2. Therefore, it will tend to move upward. Its terminal velocity will be in the upward direction. Therefore, there is a ratio of Vp over Vq. Vp is 2 r squared, not rho minus sigma. Here you have to write sigma minus rho because density of liquid is greater than object. Therefore, sigma 2 minus rho 1 g over 9 eta. Both media have same viscosity, they will be cut off. Then Vq, that is normal equation because that is moving downward, 2 r squared rho 2 minus sigma 1 g over 9 eta. Then 9 eta 2, same object, same radius. Therefore, everything will be cut off. G also cut off. Then the answer is Vp over Vq is equal to sigma 2 minus rho 1 over rho 2 minus sigma 1. Fourth one is correct, no? Right. Question number 7. Two tubes AB of length 100 cm and 25 cm of radii 0.2 mm and 0.1 mm. Its length is 100 cm. The second one length is 25 cm. Radius is 0.2 mm. Here the radius is 0.1 mm. Joined in series. Series means the rate of flow of liquid will be same. For liquid entering at A at the pressure of 80 centimeter mercury, here the pressure at A is equal to 80 centimeter mercury, and they are leaving at B with the pressure of 75 centimeter mercury. They are asking the pressure at the junction. Right. Here you can directly use one equation. The volume flow rate is equal to pi r 4 delta P over 8 eta I. The Poiseuille equation can be used here. As they are connected in series, the rate of flow of liquid will be same in both tubes. Pi is same, 8 also same, same liquid, therefore eta also same. Therefore, the variables are the radius, the pressure variation, and length. Compared to the A tube, the tube B, length is 4 times lesser. If the denominator is 4 times lesser, to balance that, numerator should be also 4 times lesser. Compared to tube A, tube B has radius half time. If the radius is 2 times lesser, r to the power of 4 is 16 times lesser. They are in the same side of the equation, they are multiplied. Therefore, if R4 is divided by 16 times, to balance that, delta P should be increased 16 times. Therefore, what is the overall change of delta P? It's multiplied by 16 and divided by 4. Therefore, it is multiplied by 4 times. Therefore, if the pressure variation in the tube A is delta P, the pressure variation in the tube B should be 4 times delta P. Altogether, variation is 5 delta P. 5 delta P is equal to, if you subtract PA minus P, PA minus PB, 80 minus 75 is 5 centimeter mercury. 5 delta P is equal to 5 centimeter mercury means 1 delta P is equal to 1 centimeter mercury. You can either subtract 1 from 80, it will be obviously 79 centimeter mercury, A minus delta P, or otherwise you can add 75 plus 4 centimeter mercury also 79. Anyhow, question number 7, answer is first one. If you are difficult to do in one shot, you can write 2 times the equation for tube A and tube B and you can just divide 1 by 2, you will get the answer. But if you can, try to do one equation. Here you can make a mistake. Instead of putting 1:4 pressure variation, you may say 4:1, then the answer will be fifth one, 76. How to eliminate that mistake? You must know it needs more pressure variation, more pressure difference across a narrow tube. Therefore, across a large tube, the pressure difference should be lower, and across a narrow tube, pressure variation should be higher. Therefore, if you make an answer 4:1, that is wrong. The pressure difference should be 1:4. Therefore, question number 7, answer number 1 is correct. Question number 8. A spherical ball of radius 1 into 10 to the minus 3 meter and density 10 to the 4 kilogram meter mercury falls freely under gravity, right, through a distance h. That means it starts to fall from rest. After it falls a height h, its velocity is root of 2gh. You can directly use this equation. Otherwise, you can use v squared is equal to u squared plus 2as. Final velocity we are going to find. Initial velocity is 0 and 2 into g into h. V is equal to root of 2gh. Or otherwise, you can use conservation of energy. This is method 1. Both are same. This equation is based on conservation of energy. Therefore, loss of potential energy is equal to gain of kinetic energy. mgh is equal to half mv squared. From that also you can gain v squared is equal to 2gh. V is equal to root of 2gh. Or the same way h is equal to v squared or 2g. Both are same. Now, after it enters the liquid, its velocity does not change, mean it attains the terminal velocity. For example, inside the liquid, terminal velocity of the object is 10 meter per second. If you throw the object with 5 meter per second, anyhow it will increase up to 10 meter per second. If you throw the object with 12 meter per second, it will reduce up to 10 meter per second. If you are throwing the object with 10 meter per second, it will remain unchanged at 10. Therefore, in this question, it is mentioned that the velocity does not change, mean it's already enters the liquid with a terminal velocity. Therefore, it is equal to the terminal velocity. What's the equation for the terminal velocity? 2 r squared rho minus sigma g over 9 eta. If the data are given, no? You can substitute and get the answer. 2 r is 1 into 10 to the minus 3, which will make a square 10 to the minus 6. Rho is 10,000. Density of water is 1000. G is 10. 9. Eta is given as 10 to the minus 3. Therefore, 9,000 and 9 will be cut off, 1000 is remaining. This 1000 and 10 to the minus 6 and minus 3 will be cut off. Therefore, 20 is remaining. That means root of 2 g is 10 into h is equal to 20. Root of h is equal to 20, root of 20, then h is equal to 20 meter. Question number 8, answer is 30. Or you can use in this equation, h is equal to v squared over 2g, as v is 20, 20 into 20 over 20 is equal to 20 meter. Anyhow, in both methods you can get. Question number 8, answer is third one. Question number 9, 27 identical drops of water are falling down vertically in air, each with a terminal velocity of 0.15. If they combine to form a single bigger drop, its terminal velocity. According to conservation of mass, if 8 droplets are combined, the radius will be double. If 27 droplets are combined, radius will be triple. If 64 droplets are combined, radius will be quadruple. If 125 droplets are combined, the radius will be 5 times larger. And if 216 droplets are combined, radius will be 6 times larger. Here it is mentioned that 27 droplets are combined, the radius becomes 3 times. Therefore, terminal velocity is proportional to radius squared. As the radius is triple, r squared is 9 times increase. Therefore, terminal velocity is increased by 9 times 0.15 initial terminal velocity into 9 is equal to 1.35 ms minus 1. Question number 9, answer number 5 is correct. This is the short method. Method 2, you can remember V is equal to V naught into n to the power of 2/3. Here n is given as 27. Therefore, initial velocity is 0.15. N is 27 means 3q into 2/3. Third and third will be cut off. 3 to the power square is 9. 0.15 into 9 is equal to 1.35 meter per second. You can practice this equation for other numbers also and check the accuracy. Question number 10. The breaking stress of a material is 10 to the power of 8 Newton meter minus 2 and its density is 4000 kilogram meter minus 3. What will be the length of a uniform wire made up of the material so that the wire breaks by its own weight when suspended? If the wire breaks, it will happen not at the bottom, at the top only it will happen because the tension increases upward. Therefore, we have to check this point. At this point, the whole weight of the wire is suspended. Therefore, force is equal to the own weight, V rho G. Instead of volume, you can put area into L rho G. That is force. Here it is given as breaking stress. Then how to make the force into stress? You can divide by area. A L rho G will be divided by cross-sectional area. A and A will be cut off. This is a cross-sectional area. Therefore, breaking stress is given as 10 to the power of 8. L is a question. Density is 4 into 10 to the power of 3. G is 10. That's all. Therefore, L is equal to 10 to the power of 8 and 4 will be cut off, 4 remaining. If you divide 10 to the power of 4 by 4, that will be 2.5 into 10 to the power of 3 meter. Question number 10, third answer will be correct.